Now we're looking at the side angle side congruence postulate. For this postulate, if you notice, this is written side angle side in a particular order. The angle is in between the two sides. We call this an included angle because it's included between the two sides. So when we use side angle side, we need to make sure it's in this particular order, and I'll show it to you in this proof right here. In the figure, you notice the given is already marked. We have BC is congruent to DA, and that's shown here and here. And then we have BC is parallel to AD, and that's shown here and here. And the other things that we can mark, I call this a side-by-side type of picture, where we have the two triangles, they share a common side. So we would also want to mark that AC is congruent to AC by reflective property. And then since AD and BC are parallel to each other, we can state that this angle right here is congruent to this angle up here. In other words, BCA and angle DAC, those are both congruent because of side angles. Because they're alternate interior angles. And so hopefully you can see the side, the angle, and the side here matches the side, the angle, and the side here. And you don't need to write those in there, but I'm just showing you visually just so you know what we're talking about. So we have enough to do our proof now, so we're going to do that rather quickly. We have our statements and reasons. Our first statement gives us our given, which is that BC and DA are congruent. Then we have that BC and AD are parallel, which is also given to us. Then we're able to say that BCA is congruent to DAC by alternate interior angles theorem. And finally, we've got AC is congruent to CA, which is our other side. Now that we have side angle side, we're able to state that the two triangles are congruent by the side angle side congruence postulate. In this next example, we're going to look at QS and RP, which pass through the center M of the circle, and we want to conclude, hopefully, that the two triangles are congruent. I call this kind of triangle setup either a bow tie problem or an hourglass problem. Hopefully you can see how it looks like a bow tie, and if you turn your head to the side, it looks like an hourglass. The first thing you want to mark whenever you get a bow tie or hourglass is these two angles right here. We notice that SMR is congruent to PMQ by them being vertical angles. The second thing you should notice here is that all of these lines, MS, MR, MP, and MQ, they're all congruent to each other, and the reason for that is they're all radii. And so now we've got our side angle side here. You can see it here, and you can see it over here. We have enough to state that the two triangles are congruent by side angle side. So we're going to do that real quick, just informally, not as a formal proof. Because of the vertical angles, we can say PMQ and RMS are congruent, and then all of those lengths are equal because they're all radii. And finally, we can state the two triangles are congruent by side angle side. This next example is going to be a proof, more or less. We want to prove that SVR and UVR are congruent. So SVR is this triangle right here, and UVR is this triangle right here. So in this case, if we look at those two triangles, we're told that RT and SU are perpendicular. That means that all of these angles are 90 degrees. And we're also told that SU and it should be SV and VU. Should be SV. Sorry about that. So this should be SV and VU are congruent. So we can state that those are congruent. And again, this is 90 degrees. That's also 90 degrees. And finally, we can state that RV is congruent to RV. And again, you can see the side angle side here. So we do our proof. We start with SV and VU, which is what it should state up there. SV and VU are congruent, and that's because that's given to us. SVR and RVU, you could either say definition of perpendicular line or perpendicular lines form right angles. And so we've got our side, we've got our angle, then we've got RV and VR gives us the reflexive property of congruence, and finally SVR, triangle SVR is congruent to triangle UVR by the side angle side congruence postulate. And we're done with this one. Thank you.